Welcome to today's tutorial. We'll be going through paper 2 from 2022, right? So let's get started. So what I'm going to do is I'm going to open the question paper. So this is the question paper. So there we go. So I'm going to take it a bit slow, right? Since there's quite a lot involved. And in order for you to like fully grasp the concepts, it's advisable to take your time, right? So I'm gonna take my time. So question one is based on the unified modeling language, right? So you make UML diagrams. So you make class diagrams, right? So we're gonna start on that. So draw the UML class diagram to demonstrate the concepts of inheritance, composition, and interfaces by considering the class car, right? So that means they even gave you like an illustration, right? So yeah, so there's the illustration. I'm not sure. So let me think. Hmm. In terms of the composition part, it's going to be tricky. This is the one question I do not like because you have to like really, really think, right? And when it comes to UML, they don't want you to do everything. Make sure you read the instructions. What does it say here? It says constructor and property methods do not count. So in the I missed doing your UML diagrams, right? Or in the process of doing your UML diagrams, do not include constructor and property methods. Do not, because they don't count for any marks. Hence, that's why it's only worth 2 marks, right? So they say they should have at least 2 attributes and 1 appropriate method. Remember, property methods, they do not count. So even if you have attributes that are private, it's fine. Leave them as private. But since we tend to have inheritance, if you see question 1.2, it says define 2 additional classes which both inherit directly from car. So the car is going to act as a base class at some point, right? Before we even start doing the UML diagram, we need to understand that. So that means these attributes, instead of them being made private, they're going to be made public, protected. Because remember, with protected, within it's like a family secret, right? Within the it's something that's public only within the inheritance hierarchy. If you did biology or you just have common sense, you were born from your parents, right? And there's some things that they taught you that other people don't know, right? So that will be protected. It's like a secret kept between you and someone you're related to, right? So since we have inheritance, so we have some sort of relation, right? Or we're gonna have classes that are going to be related to the car class, right? So hence we're gonna have to have protected. So what I'm going to do is I'm now going to open Dia, which is the tool that you guys should be using to do this. But since you'll be writing it on a piece of paper, you're not necessarily gonna do it this way. You're gonna write it on a piece of paper. So I'm gonna click on the class icon and then click again here to paste it. And then I'm gonna double click on it. Okay, it seems like it's taking its time. So there's the properties, right? So there's the pop-up. So I've clicked it and there's the pop-up. So now what I need to do is I need to give this class a name. Remember, this class should be called car because it's a class that represents a car. And then attributes, these are your variables, right? Those are attributes. And then operations, these are your methods or functions. But then they're called methods part of a class. So when those functions become part of a class, they're now called operations or methods. So hence they use that term operations here. So I'm gonna have attributes, click on attributes because I need to start with attributes. And remember, this is an open-ended question. That means you have to come up with answers. So yeah, let's try to be as creative as we can. So we have to try to be very creative. So this is the question that I do not like because you spend a lot of time thinking. If it was, if it were up to me, I would advise you do this question. This question should be the last question you do because you need to invest a lot of time in it. Then all the other ones you try to do them as quickly as possible. You see, it's 5 marks. They expect you to take 5 minutes to do this. So yeah, and then this one they expect you to take around 15 minutes. But since I'm explaining, and on top of that, I have to come up with the answers. Since I didn't Google them or anything like that, I have to come up with the answers. It might take a longer time. So let's see with the car. What attributes can a car have? So you click the plus icon to add an attribute, right? So I've clicked add, and then now I can add an attribute. So what do I want to add? What sort of information can be stored for the car? So remember with object, so let me open Notepad plus plus. With oriented programming, right? We are mimicking the objects in the real world and putting them in the digital world, which is the computer, right? That and those objects are like, for example, just like here, you see, this is a glass of wine, a wine glass, right? So that's an object. It's a physical thing, right? So each object has certain traits. It has things about it which is like characteristics. So, for example, how much it weighs, how big it is, things like that. Those are properties of those are what we would call properties or characteristics of an object, right? And then those characteristics, right? They are what we call attributes, right? Attributes, and then these attributes, it's basically variables, right? And in in simpler terms, we use nouns, right? Anything that you can think about of an object that's a noun, then you know that that automatically qualifies it as an attribute or or a variable, right? And then we have another thing that we use to represent an object. The other thing is functionality, right? Basically, what we can tell the object to do to itself. So I can, for example, grab a tennis ball or any ball, right? And then spin it, right? When the ball spins, who's spinning? Is it me or it's the object itself? Is the ball itself, right? So it's doing that action or performing that functionality on itself. So therefore, we say that functionality, this is functionality, or in other words, they use many words. Remember, English is like there's synonyms for things. So these are sometimes called operations, these are sometimes called methods, but then at the end of the day, these are just functions, right? To represent functionality. Basically, this is since it's functionality, it's an action. So we're gonna choose verbs, which is like doing words, right? We're going back to English now for those who think they could run away from English. So we choose verbs. So to make an example, right? Um, a simple example. Let me think of an example. What example can I make? So let's say a person, right? So a person, let's say we have a person object. So what are the characteristics of a person? So a characteristics person is like basically information about the person, right? It's like what can we know about the person or that object or that thing? So person, we can know their name, their age, um, their what is this? They whether they are single or not is single. We can know all those properties, right? Or all those characteristics. And then number two, we can know what a person can do on themselves, right? Basically, this is like the methods, right? And we typically choose verbs. So a person can run, right? And a person can jump. You see, these are verbs. there's that doing words, action, right? So with that being said, we need to come up with those two things for each object or each class we're going to create. Remember, the class is actually the plan for to build the object. It's like, obviously, a person wouldn't have a plan. You wouldn't know. So the person who who has the plan would say it's God, right, or a creator, whatever you believe in. So that creator is the one who has the class. So the creator is the one who has the class, which is the template or blueprint. Remember, English has synonyms, or a plan. You can just view it as like a plan, right? The creator is the one who knows how this person is going to look when they are born. Same applies with building houses. You have a house, and there's a past paper that is or that talks about houses. So you have a house, you can have a house class, right? Which will serve as like the blueprint or plan, right? Which is how you're going to build the house. What features is it going to have, what color, and things like that. Okay, all those plans, right? Remember, those plans, they're going to be part of a class. And then that class is going to have characteristics and methods. So that's pretty much what are you going to do here. So let's come up with the characteristics and methods. So for a car, I would like to know the model, right? So the model number. So what model number is the car? And then I would make it an integer, right? And then remember, visibility, it has to be protected. Remember, we have inheritance. Since we have inheritance, I would have to make it protected. If we didn't have inheritance, I would be forced to make it private. And then if I needed to access it, I would create property methods. But in this scenario, they do not care. Don't create constructors. Don't create property methods. Don't do those two. Don't waste your time. If this question is worth 2 marks, that means it should take you 2 minutes to do this question. So yeah, that's pretty much it. And then the second thing that I would like to know is what brand is the car, right? And then for here, I'm gonna make it a string because I want to know what brand it is, right? And then the brand is like, for example, BMW, Mercedes, things like that. That's what we call the brand. And I also make it protected because remember we have inheritance. And then I'm gonna click apply, right, to apply these changes. So now I have these two attributes. If I put this away, you see that it also updates my class, my model, right? So I'm gonna continue. So now I go to operations. And I only need one operation. Remember, this is worth 2 marks, 2 marks, right? It's not, it shouldn't take you a lot of time. You must have at least two attributes. We did create those. Now we are lacking one appropriate method, right? To be honest, this was a really bad example, but yeah, you just have to work with what you have, right? So I might take time to come up with answers for the when it comes to all the other classes, but here shouldn't take too much time. So remember the base class, right? What's the whole purpose of a base class? Base class is basically you're avoiding this thing of what is this? You're creating this whole point of reuse, right? So you're taking all the common functionalities in all the subclasses or the child classes or from all the children, right? All the common traits or all the common things, and then you put them inside one base class, which is sometimes called the parent class, right? So car is like the ancestor, right? Can or the parent for all the descendants, right? So therefore, I need to have put in common things that are common in all of the children. So by common, it means like, for example, when you are born, right, you have a nose, right? Hopefully, you're born with a nose. So you have a nose. Both parents, both of your parents have a nose, right? So therefore, it needs to be inside the parent class, and then we declare nose inside the parent class because it's common amongst all of their children. So the same applies with car. So obviously, all cars can drive. right? They can move, right? Remember with um, functions, right, or methods, we choose we use a verb to choose those methods because it represents an action or a thing that the object can do to itself. So I'm gonna choose drive because a car can drive, right? You can drive a car, right? So the car can move, right? And then I'm done, and then apply, and then okay, and then there it is. Okay, so I forgot to put in the return type. My bad. So I'm gonna double click it, go to operations, and then go to the type, which is the data type or the return type, and then I'm gonna make it void, right? Because it doesn't really, you shouldn't get back anything. It doesn't really matter. And remember this question, they don't really care, or whatever approach you choose. You can make all your methods void for all they care. So yeah, so there's the car class, right? So there it is. I'm gonna put it there slightly on the top, and then I'm gonna grab another class diagram and then grab another one here because we have inheritance, remember. So I'm gonna need two descendants or two child classes. So while that's, I don't know why it kind of takes its time to load. Yeah, I don't know what's that all about. So define two additional classes which both inherit from car. So this question is very, very tricky, right? It's very tricky. So it's a very tricky question because in your mind you'd be like, well, the only two cars that I can think, you can there's okay, I'll say there's two ways you can approach it. You can choose cars, right? You can say you can actually choose a model or a brand, actually brand, right? And say, for example, I have a Volkswagen, or I have an Audi, or I have a BMW, right? So you can choose the actual models, and then those two classes um, will be the will be the child classes, right? Or you could say there's another approach, which in this case, which would be more correct. There's another approach, right? Because I mean, BMW car is a car, right? And then an Audi car is a car. So there's another approach. You can choose. Remember, there's different types of cars. We have a what is that? We have a buggy, right? Which is a car, but it's a buggy, right? And we have a sedan, right? Which is still a car. But then remember, the sedan is like the one that the longer one, but it is four. But yeah, it's a sedan, but it usually has four doors. But then it can be two door. But yeah, so that's the other those are the two approaches you can take. That's literally up to you. But then the tricky part is if you choose a sedan and then you choose a back, you can you can come up with things, whatever you can come. There's things that you can come up with, but to keep it simple, I would just choose the actual models, right? The actual brands. So BMW, I don't even know what I'm gonna put. What would be unique in a BMW, right? That's so. Let me see. Sedan, buggy. Um, let me see. Should I? I could. Let me think. Should I? Because if I try to come up with this, like I said, this question paper is so open-ended. My mind I'm thinking about a lot of things that you can put here. Not entirely sure what exactly can I put. So let me think. You need to create two additional classes, and then you pretty much do the same thing, right? And then pay attention to the brackets, right? Constructor property methods and overridden methods do not count. By overridden, it means that the method inside the class, base class, this drive method, it's irrelevant. Don't even think, consider it as like it's non-existent. Even the variables that are there, consider them non-existent. They forgot to say, they forgot to say, yeah, they each have, yeah, okay. They did specify, so because they were supposed to specify even to tell you that even the attributes inside of your base class do not apply to your child classes. So what would be unique? Let me see. I don't even know. Okay, so for attributes, right? For let me see, for attributes for a BMW, right? I will remember here you can play around with it. For attributes, I'll say type of car, right? I'll store what type of car it is because remember BMW can come in a sedan form, it can come in a like those family cars. I forgot what's the actual name for them, but then it can come in that big form, right? So I'm just gonna say type of car. What type of BMW? What type of BMW is it? But then it's the thing is, yeah, this question's this is a very annoying question. The thing is, there's things like model, right? But then they say it's the model number. So okay, it's different. It's the model number. So I'll make it a string, just define what type of BMW that is, and then private because by default it should be private. We use protected because we have a base class. Remember in UML they're trying to see that you know all of the notations. They want to see protected, private, and public. They want to see all of those things. There's a lot of things that they want to see. And oh, I forgot to do this. So let me apply here and then click OK. I forgot this is informatics. You guys do things a bit different. So before you actually display the method or property method, you specify what type of thing, right? So I'm gonna go here and then I'm gonna create new and then move it up. And then I'm gonna say this is my methods, right? I totally forgot to do this. You guys have to do that. You have to specify everything underneath is going to be a method, things like that. And then double click. So what else can I store about a BMW? Mm, so what type of BMW it is? I can store. I can also store what type of engine. Like, is it a V12, V8? Like, what type of engine, right? And then string. I'm just literally coming up with things here. You just come up with things that make sense. The type of engine that's there, that it also makes sense, right? Because it's an engine. Oh, you could. I should mix it up. I should. I could. Yeah. Let me make it a bit simpler. Let me instead of type of engine. Let me say this is the year. So year released, right? The year it was released. And that's a simpler attribute to come up with, right? And then what other you see that's why I say this example that makes no sense. What other property method can you come up with here? But then we'll have to come up with something. So let me see. You can drive a cooking. It's any method, right? I could. I'll come up with a simpler, very simple method. I would say fill up tank, right? To or to just say is tank okay, is tank full? You can just make it an attribute, right? Yeah, you can just make it a you okay. You can still yeah. I'll make it. I'll create a function called this tank full, which tank checks if the tank is full, meaning that should I pour more petrol and things like that, and then apply and then okay. That was too much for my brain. But yeah, so we have something here, what type of BMW it is, and then the year released, and then the methods is thankful. And then here I'm going to say this will be a Mercedes Benz, right? And then for Mercedes Benz, let me see. Uh, what else can I come up that's related to a car? Hmm. I could, you can come up with very simple examples, right? I think I'm overthinking it. So I can store a variable and say here's radio, right? To check if it is a radio. Because cars do have radios, right? Or you can say here's screen, whatever you want to call that screen, right? Whatever you want to call it. But I'll just check, store a boolean variable that check if it has a radio. So it's boolean and then private, because the main thing they want to see is the UML notation. But then you need to come up with variables that make sense. You can't say come up with the Mercedes Benz class and say and have a function that says toast bread. It makes no sense. A car can't make toast, right? So that's why you need to come up with variables that actually do make sense. And then is okay, so I can check if he's thankful. I can check. I can keep track. There's many things I can keep track of a car, right? I can also keep track of if it has been when was the last time it was serviced, right? So I'll say last time serviced, so that I keep so that I know when I should take it back to save it to get serviced, right? Remember, to service is like for those who don't have cars, but then you don't actually need a car to know these terms. For a car to get serviced, it just means that it's like maintenance, right? If you regularly take it, it's like for checkups. For example, the same way you go to check up your body, right? The service, a car service is like they're doing the exact same thing, but then instead of checking you, they're checking the car because it's a car service. So last time serviced, which will be an integer. So let me see. I can make it an integer. I need to store the full date, like the time and the date and the time. I need to store them both. So I'm gonna make it a string. So last time it was serviced and then apply. But then remember, this needs to be private, not public. And then apply. And then operations. I need to put in and specify that this will be the methods, and then I put in the actual method. So um, for the methods, right? What else can a car do? Mm, let me see. A car can drift, right? But you can put that as a feature. So I can say drift car, right? Just drift the car so that it comes out smoke, whatever, to just impress the ladies or whatever you want to do with that, or impress the bros, whatever you want to do with that. You can drift the car, and then void, and then that's pretty much it, right? So these are the two classes, right? Or the three classes that we have so far. And then the last one, Even though it's a long journey, but the last one. Give an example of an interface implemented in class defined in question 1.1. Give an example of an interface implemented. I don't know whether they want you to actually. Okay, this is UML, right? Oh, so they're testing everything. So you have to define an interface here. Don't know how you're gonna define the interface using UML. Let me see if we have an interface here. I doubt it. I don't think there's such. Yeah, I'll just create it. I'll just create a class and put. You see the same way I put methods here to signify that these are methods. I'll put somewhat of an annotation at the top to say this is an interface. And I forgot the UML. The interface it's what the diamond, right? No, it's not a diamond. Implements. Let me see. Yeah, implements a specific interface. Yeah, I see the implements specific interface, but then they don't specify. Okay, I guess I have to create it in my own way, but I'm gonna do it in that way. I'll signify an interface later. Remember, an interface is just basically a list of things that that object can do, right? You can put variables, attributes, it's fine, but then most of the time it's all about, and it always starts with an I, for example, I can run, I can jump, right? Things like that. So that means you have to come up with an extra function. These people they don't rest. So we have to come up with another. Or just when you thought it was done, we have to come up with another example there. So to demonstrate, okay, this is okay. I just thought of a, excuse me, I just thought of a simpler way to come up with that. So now we need to come up with a class that demonstrates composition, right? So the class that demonstrates composition, I'm gonna put it this side, right? And then for interface, I'm gonna put it this side. So I'm gonna double click, and then this class will be, I'll call this class seat, right? Why seat? Because each car has a seat. Because remember, using one of the derived classes to demonstrate, oh, I need to use one of the derived classes. So one of the children or child classes. So remember what composition is, right? It means that has a relationship, right? But then let me think about it. But yeah, it's true. You can. Why would you? Why, remember, a car seat is different from a normal seat or normal stool, right? So it can remember compose. There's two types of containment examples, right? There's composition, then there's aggregation, which is they're both has a relationships, right? But then the only difference is that with composition, there's a life cycle dependence. Basically, that thing that's inside of that object that's inside of the other object, it cannot exist, or it wouldn't exist if the object that has it didn't exist. So what do I mean by that? So for example, the heart is contained within a human being, right? If the human being, which is the object that contains the heart, if the human being didn't exist, the heart wouldn't exist. So that will be composition. There's a life cycle dependence. And why are we calling it life cycle dependency? Because its life cycle is dependent on the outermost object, which is the human being. What does that mean? For example, if I eat bad and I eat unhealthy, I have a heart attack. That means I'm polluting my heart. I'm eating things that do not go well with the heart, right? and then they end up causing me a heart attack. So its life cycle is dependent on the person. So we need to really understand um, composition, right? And then aggregation is the opposite. There's no life cycle dependency. It's like one thing can exist without the other thing. So, for example, Tabo has a girlfriend. They have he has a girlfriend, but it's not like a life cycle dependency thing. His girlfriend can exist without him existing. Even though you might be like, "Whoa, I love my partner," blah blah blah, but the fact remains you were living the whole time before you met them. So you can't say you cannot live without them. You're just saying that figuratively, but in terms of facts, you are actually living without their existence. Don't be like, yeah, I can't breathe, no air, whatever. When Joe, Jordan Sparks and Chris Brown made that song, know air, you'd be like, I can't live without my partner. It's like they're my oxygen. Don't lie to yourself. That's aggregation. There's no life cycle dependence. You can live without the existence of the other thing or the other object. So this is the two differences, right? So we have that understanding. So you can choose anything. You can choose an engine, for example, right? The thing is, the reason why I'm avoiding engine, it's too complex. Because to go for an engine, you'd have to actually understand an engine. But the simple example here would be for composition would be an engine, right? But then I will okay. They said composition. They didn't say aggregation. They said composition. But then for you guys, I'm not sure if they did talk about aggregation. Yeah, I don't think for infos they do dwell into those details. So it's fine. I'm gonna create a seat, right? And then that seat, I'm gonna what attributes can the seat have? So which it's simple, right? I'm gonna have number one color. What color is the seat? And then apply. And then number two, what fabric was used, right? And then apply. Done. Then with operations, that can be the tricky part. But then let's see what we can come up with. So a car seat, what functionality can it have except sit on it? Yeah, that's the only example that I'm thinking of. It's a car seat. You can sit on it. So I'll literally create a method called sit on it, or just sit. Right, that's the functionality. That's what you can do with the seat. You can sit on it. Remember, sit is it's spelled to this SEAT. That's the actual seat, the physical thing. Sit, which is the action of you being on top of the seat, it's spelled SIT, right? Even though it sounds the same. I'm talking about two different things. When I say yeah, you should be able to sit on the seat, it's two different things, right? So that's pretty much the things we need. Then last but not least, before we put in the notation, right? Because remember, this is be sure to use correct logic and UML notation. So the correct UML notation to get this full 5 marks at the end, did you use hash for protected? Did you use minus for private? So that's those are all the things that they're testing. So remember when you use minus, right? This means that attribute is private. And then if you use plus, it means that that attribute is public, right? And then hash, and we did talk about these property methods, right? There's access modifiers. I mean, we did talk about them. Private means that only you have access to it. Public, it means that everyone has access to it. This is those people, your Mbalis, Abombali, Sneh, Balisa, all those ones. People have it's access. The public has access to it. Everyone has access. Keep this example in mind. You'll never forget about public. Protected, it's like a family secret, like I said. Only you and someone you are related to knows that thing. So, which means that it's public to people within the family tree, but then it's private to any outsider. If you're an outsider, then it's private. So they to get the 5 marks, they need to see all three of these in your year month notation, and you applied it in the right place. So, for example, car, the attributes you've made them protected, so they see the hash, so that they see that, they see the minus, they see the plus, like, oh, this person actually understands your mark. So that's how you're going to get your marks. Then here I need to create an interface, right? So I need to create an interface. So remember, the interface starts with an I, right? Meaning I, meaning me, that object can do something. For example, I, a person, right? I can speak. That's an action, right? So I can speak, I can run, I jump, or I speak. You see, I. So hence it starts with I. Then they're checking all these things. If it doesn't start with I, you lose marks. So make sure it starts with I. Like I said, we're gonna take our precious time explaining these things bit by bit. So I have I, and then what what this is going to be tricky. What can a card do? Right? That's the tricky part. Because they want to test your interface. So let's think about it. What can a card do? Let me see. A car can, what can a car do? Because now I'm running out of ideas. So there's a car, there's windows, blah blah blah, wheels. Um, so let me think about it. So a car. What else can I put? This is the questions that I do not like. Ever since even the time I was doing this module, I never liked this question because there's so many possibilities, and you just get so caught up in the moment, don't even know what exactly to write. What can a car do? So let me see. So a car can park, right? You can park a car, but that's a bit vague. Mm. Or a car can speed, even though it's a driving. Technically, it is driving, speeding and driving. Okay, it's not really the same thing because there's even two words for it. It's two different things. So I think inside of the base class, right, I should have come up with a different function, right, or the different method. So let's come up with something. So I drive. I think drive is like the main functionality of the car, right? So I think I should make that an interface. Then I put in a drive method within that interface. Then within the abstract base class, I put in another method that makes sense. So I think I'm going to choose that approach. But before I do that, let's think about what other method can we put for a car. Um, we could keep it simple, right? So it's fine. I'm gonna, say I drive, right? and then I'll just only put in operations, right? Which will be methods, and then apply, and then new, and then it's going to have a drive method, right? That's as simple as it can be. That's what I'm going to do. But then, even though it is an interface, we can see that, but under stereotype, I can just say here interface because it starts with an I, they can see. But then sometimes it's always good to put a stereotype. Okay, stereotype basically is sort of like a label at the top to dignify or to define or denote what this thing is. You see, this is an interface. There's a classes already. You can tell. I don't need to specify this is a class. The only time I need to put something if it's it's when it's like an abstract based class. I have to put that abstract keyword there. So I drive, and then here I, I just thought about something. The lights. I can say um you have a method that checks if lights are on. Are lights on? And then boolean. It just checks if the lights are on. You could also have like not are lights on, is lights on. English. It's fine. I'll just leave it as are lights on, right? Or you can come up with something. I don't know. Maybe you guys can come up with something more creative. What other method can we? Yeah. Or you can say has insurance, right? You see, I'm starting to come up with a lot of things, but then I'll just leave it as a lights on. So now it's time to put in the UMO notation, and we are not done because remember the last question, question at 1.5, correct UMO notation. They want to see the notation. So implements, right? So I don't know if it's this way. No, it's not this way. So this, I hope this is correct. Yeah, I hope so. So let me just double click. That's fine. So yeah, I'm not sure if this is correct. Let me see. This implements. Nah, it's wrong. It has to be this way. Yeah, I think I'm sure now. It has to be this way. So this implements this. So basically, this is like a part of that, right? Sort of like inheritance. You see that it looks, and yeah, it is inheritance, to be honest. You see that it looks like inheritance, right? And then it's dotted in to denote that there's an interface. I didn't have to put in this part and say it's an interface. They can see, but then I just put it there to make it easier for even someone with no UML experience to know that that's an interface. And then inheritance, which is generalization. So generalization, there we go. I put it here and then scroll down here. Then I'd grab another generalization arrow and then I link it here. And then there we go. So there's the generalization. And then the last but not least is the seed. So this seed is this aggregation. So it's a part of this because each car has a seat. And then I need to double click. Okay, it can be, remember we need to denote composition. So I'm gonna change this to composition and then apply, and then it's gonna shade it in right to black. That's composition. If it's not shaded in, it's aggregation. You see, it's white. It's not shaded in. But then when it's composition, it becomes shaded in. And then there's your UML diagram, right? And then that's all you needed to do. Then I'm going to export and then downloads, right? And then let me do this. Let me see, export by extension, right? So I'm going to export it as a Cairo PNG, right? And then I'm going to name this question one UML. Then I'm going to save it here. And then I can try to open it as an image now. So let me open it. So there we go. There's the diagram. So we are done with question one. So now I can close this, then just say close without saving. I don't want to save this dear diagram, not necessary. So now we come to question two, which is recursion. So let me check. Okay, there's quite a lot of things and a lot of time that I took, but then you should the main goal is for you guys to understand. So I'm gonna take my time. So you see those there's questions, right? If you check, there's some questions like general knowledge, whatever. You go read the slides. I don't do those questions. I don't answer those. Even this one, I do not answer this. See, there's you have to go. There's the slides. I can't go read for you and then put it in a video, only for you to just only watch the video, not look at the slides. These questions are for you. I don't. That's not way I answer. I don't answer those questions. So recursion. So let's look at recursion. So question two, right? So here I'll leave this, right? I'll just leave it there at the top, and then let me copy this, and then I'm gonna say this is question two, right? And then I'm gonna put this, and then I'm gonna specify this is the end of question two, so that you can tell the difference. So this will be this is paper two, right? So paper two or paper B, 2022 answers, right? And then save as a normal text file, right? So let's start with solving this question. So we'll start with A. So A is 5 marks. So in terms of X, Y, and Z, what does the following function calculate? So in terms of, you're looking at in terms of X and Y and Z, and then they want to know what's basically you remember in high school when you had like numbers, right? In it, you had a sequence, and then you had to find a general term. That's basically what you're trying to do here. You're finding a general term for this function. Hence, they said in terms of X, Y, and Z. So that means your final answer must use X, Y, and Z. That's how your final answer should be. So this diagram, if you remember, if you've been watching my video, I explained it very simply. I'm just gonna explain it again, but then I won't go into too many details. So there's the function. So if you look at our function, right? Remember, this is a recursive function. It's basically a loop, a for loop. But then it's a for loop because we know exactly how many times it needs to run and when it should stop, right? So that means it stops if if A is less than 1, then stop. That means it basically stops when it's at 0. And then they even put a comment here. They said, assume that this will always start at 1, at least 1, greater than or equals to 1. That means 1 to infinity, right? So that means when I make this example, or when I make try to find the formula, I must start at 1. X, remember, the only thing that's changing, okay, they said A. They made a huge mistake here. They made a huge mistake. It's Z, not A. So Z is less than. Because why am I saying Z? Yeah, this question paper was flawed. I hope someone in class asked the lecturer that what's going on. You said A here, but then there's X, Y, and Z, blah blah. So you look at the one that's changing, it's Z. Obviously, Z, if the Z is changing, it has to stop at some point. So that means here they meant to say Z. So Z minus 5. So you see that it's decreasing in terms of 5. So that means I must pick a number that can be subtracted in terms of 5s, right? And that is basically a number that's divisible by 5. You can't divide it by 5. I'll choose 20 because I want at least 4 steps, or 25. It's up to you. As the more the merrier, right? The more the steps you have, the more you can easily see the pattern. But I'll choose 20. So I'll say let my Z be equals to 20. Hopefully I should see the pattern, but then me, I typically see the pattern after I've done my tables and stuff. So let me do this. So okay, it's fine. I can just, so let me make the table. So X and then I'm gonna need this exact same space, and then Z, Y, Z, and then calc R, which takes in Y, Z. Um, okay, my laptop is, its response is a bit slow. So this is everything, right? But seems like I need more spaces because I know this is going to be quite a lot of solving, so I need more spaces. So there's the table, right? You could, if you wanted to just put it in like literally tabular form, you could do that, but then I don't see the need. Yeah, to be all this extra, I don't see the need. But you can just put, obviously you can write a piece of paper. Yeah, actually make it a table to make things easy to see. Make sure you have a ruler. If you don't have, take 2 pens, use another pen as a ruler. Think outside of the box. So calc R, which takes in XYZ. So like I said, we're studying at 20, right? And I did set my Z to start at 20. But then remember, during that whole process, right? During that whole process, X, Y, and Z, X and Y always remain the same. So I'm going to start at 20, right? And then I'm going to say calc R, which takes in X, Y, and then Z. Remember, Z is always subtracted by 5. So that means it's going to be the current value of Z, right? Which is 20 minus 5, which will be 15, right? So this will be 15. And then I'm going to have X. And then I'm just going to repeat. I'm not going to waste time. Just going to repeat this 4 times if I'm not mistaken. So Z is 15, right? We've changed Z to 15. So in the next step, Z should be 15 because we've updated Z. And then here, this would be 15 minus 5, which is 10, right? This will be 10. And then in the next step here, Z should be 10. And then 10 minus 5, that will be 5, right? And then this will be 5 over here. And then 5 minus 5, what is 5 minus 5? It's just 0. Okay, that's fine. It's just 0. So that means in the next step, because remember they said you stop. I'm not done right yet, right? They say I stop when Z is less than 1. And is 0 less than 1? Yes, it is. So Here it's 0. And then they said when it's 0, when it's less than 1, what should we return? Instead, they want you to return 5. So therefore, I'm going to go back here and return a 5 here. But then when this function is called calc xyz, and these are the parameters. Remember each step here. Step 1, step 2. This is what happens. This is what happens when we call a calc R with those 3 parameters, right? That means we're gonna get back this because remember there's the return keyword. This last step, it just means what are we returning, what are we getting back. So we're getting back this function, but then with z reduced by 5. And then we keep doing that in all of the other steps. So when this function is called with these parameters, x is x, y is y, z is 0. Remember it starts here. Is z less than 1? Yes, it is. So therefore return 5. Don't return this formula. So that's why I returned 5. And then now, this part, right, we didn't know what the answer was, but then you see there's the answer here. When we called this function calc r when and the parameters were x as x and then y is y and then z is 0, the answer was what? 5. So here the answer should be 5 again, right? And then oh wait, I'm missing something. I knew something was missing. It's x times y times that. So my formula is wrong. So I thought something was missing. So, and remember the round brackets that are there, they are there for a reason. They affect your formula. If you don't put them, they're gonna affect your formula. So this, then this, then this. But then, like I said, we know this answer here is going to be a 5 because we see that here when we call the function with those exact same parameters, the answer that was returned is a 5. And then now this part here, there's x, y, and 5. We know what to return when those parameters are passed. We should return this. So I copy this, put it here, and then we do that over and over, right? So basically, I hope you should see the pattern because this is very, very simple math. This is nothing complicated. So we have these parameters x, y, and 10. This is where we call the function with those same parameters. But then there's the answer for that. So I can just simply substitute the answer there. I put the answer there. And then the same applies here. Put the answer here. And then the tricky part is coming up with the formula. So the next step, right? What I typically do is I rewrite all of this, right? I know this is going to be a long process. It's just for those who are unable to see the pattern. So after this, you simply do another table, even though the lecturer might not do this, which is right, which is fair because you won't have time, so you shouldn't be doing so many things. So you do another diagram, and then you say this is your z, and then this was the answer when that the z was that value. So now you want to see this in terms of z, because remember we can see this, right? We can see xy, but and then okay, no, that's not the important thing. But then remember, z was the one that was affecting our equation or our answer. So there's everything, and then now the last step is to add up the exponents. Remember, like I said, this is very basic math. X times x is basically x to the power, right? I can't draw it. So to the power of 1 plus 1. Why 1 plus 1? Because x times x, any variable, it has a default exponent 1. If it's even so, you can omit the exponent and not say x to the power of 1. So this would be basically x squared. Hence we get x squared. So that same property in math, which is very basic math, you can be doing a BSc degree and you don't know such basic math. So you have one, two, three, four. So I have four of those, right? So that means this will be to the power of 4, right? And then let me check something. Something is very important here. We are, like I said, how you write your formula, it affects everything. So remember, we said this whole thing times that. So that means, okay, it doesn't really matter in whatever way. You can put the round brackets or not, that's fine. But then you can do this also, right? You put round brackets just to denote that this exponent is only part of this. Then after that, you can times it by 5. And then I do pretty much the same thing. How many x times 1 times y's are here? It's 3 of them. So to the power of 3. And then here, how many x y's are there? It's 2. So x times y to the power of 2. To the power of 2. And then here, even though it's not important, but then some people, they just tend to be blind. So I'll put it x to the power of 1. So we have everything. So we need to see what happens to z with respect to its current value. You see, there's 4, there's 5, there's 20, right? How did I get to 4? How did 20 change to? So basically, this is the question that we have. It's 20z, right? And then I got a 4. So what was z? What is actually z? How is z affecting this equation? So z, the answer will be z. Okay, this is not the way I want it to be. Okay, let me not put it in that way. But then z changed from 20 to 4. How did it change to 20 to 4? And it also changed, and that same formula, it needs to be applicable to this next second step. Z changed from 15 to 3. So if you're, this is very, very easy, guys. Don't come up with excuses and be like, yeah, well, it's very easy maths. You can give it to a grade 9 and they'll figure it out fast. It's 15 divided by 5. So that means z is being divided by 5. So that means to find the exponent, we are dividing z by 5. So that means, if you remember in maths, T of n, or that final answer, the actual formula is like that. But then remember, this is code. I'm just going to say final answer is equal to, I just choose any one of them. Even here, 5 divided by 5 is what? It's 1. So yeah, our formula does satisfy the equation. So to find the exponent, we say z divided by 5. And then this is our formula. So x times y to the power of z divided by 5. And then that final answer, you times it by 5. You see why it's important to have the brackets, the parentheses. You remove the brackets, your equation becomes wrong. Because if I were to do this, to remove this bracket here, it means that it's x times y to the power of this whole thing, which makes your whole equation wrong. If you did pure maths, you should be very careful. You did pure maths. You can't be in comp sci when you didn't do pure maths. So yeah, this should be a free marks question here. Once you find the steps and you know how to make those tables, you'll be fine. So the last question, question B, in question 2, write the recursive function based on the formula and Visual Basic. This is also very easy. They just say write the basic function. So I'm just gonna call it the way it's named. They say Hanoi, right? It generates the Hanoi what sequence. So I'm going to go to my here, and then I'm going to copy this, and then I'm going to say question 3, right? And then I'm gonna denote where question 3 ends. I'm gonna say end of question 3, right? So that's the end of question 3. And then no, not question 3. It's B, man. I'm still at question 2. My bad. So it's B. So I'm just going to separate this for those who cannot see. There's just students who just can't see. I don't want someone pissing me off, asking me questions. Where's this question when they can clearly see? So I'm gonna say this is question B of question 2. As you see, I haven't reached the end of question 2. Some students, they like to get on your nerves. I just don't understand. But yeah. So I'm gonna have this Hanoi function, right? I'm gonna call it Hanoi. So you can make it private or public, whatever. So I'm gonna say private. So to sort of like highlight, I'm gonna choose and change the Visual Basic language so that it highlights everything that's in like anything that is a Visual Basic keyword. So private function, and then followed by the function name. So the function name, like I said, I'm gonna call it Hanoi. You should use capital letters. So I'm going to use capital H. So Hanoi as, and it returns an integer, right? Remember, it's a sequence. It's going to return. I don't know if yeah, I have to return an integer, yeah, because it's a recursive function. You see, return 2 or the plus 1. You see, there's no floating points here. There's no decimal numbers here. So it's going to take in n as described in the question paper. Do not say x. Don't say your own things because they can penalize you for that. Remember, you can't all get distinctions, right? They need to like, if they see a lot of students pass, they can become a bit more strict. So, for example, if you use x, you lose marks. Because if all of you guys get 100%, it will also be difficult to choose like which people should you make the top 10. So yeah, hence they're gonna become strict. So be very careful, follow the exact instructions. Like I said, if you named the function the way they've named it here, you see things just become very, very easy. So every time you see with the recursive function, right, when you return an actual number, that's the stopping point, or that's what we call the base case, or that the exit case when it exits. Remember, recursion, it's repetition, right? It's going to repeat the steps in infinite number of times. So you need to put in what we call a base case, which is like a stopping point. You're telling it, okay, even though you are repeating this, stop at this point when you get this value. So they say when n is equals to 1, then you should return 1. Else, you should return 2 times the function called, you call the function again, then plus 1. I think it's supposed to say minus 1 here. Yeah, so minus 1. And they said if n is greater than 1. So you see here, right? They said if n is equals to 1, you must put equals to 1. I know you're tempted to say less than or equals to 1, right? I know, but put equals to 1. And then here it makes sense because they said greater than equals, just assume that the n value they will pass will be at least greater than 1, so that it at least runs once. So this is the full recursive function. Like I said, this is very easy. So this will be your base case, which is like basically the exit case. And then this is your recursive case, which is like the repetitive case. Why repetitive case? Because it gets repeated a lot of times. So that's pretty much how you're supposed to structure this function, and then you get your full marks. which is 5 marks. So yeah, and then you get your 10 marks and then you're done. And then let's see. I'm not sure what do they mean here by overriding with extension. That part I'm not really sure. We'll see when we get there. So let's see question 3. Let me see how far. So okay, the video, but I thought okay, just that I spent a lot of time on question 1. But yeah, I see we are now moving in the right pace. So I think I will stop at collision handling, or I might just do everything. I'll see. I might just do everything. I'll see. Let's put everything in one video. It should be around 2 hours or 3 hours, somewhere there. So consider the following classes. We have the sport, which is the base class. Then we have soccer, we have golf, CSGO, don't know what's that about. And then for FRM question 3, which is this question 3, right? So let's see. We could, let me think. And this question was, you need to think critically. I just realized something because I was trying to find out the composition part, but then I just realized something. You see it when we get there. So using the classes provided above, demonstrate that you understand the following programming concepts by writing sufficient and appropriate Visual Basic code. You see, they want Visual Basic code, not design. Design was there at the top. We're designing here. Done. We don't do design no more. We're now on the physical code. So we want code here. They want code. And then, i.e., that is, the code must be relevant to the above classes. So the code must make use of these classes to illustrate the concepts described below. And then now it's going down. So let's start with A, right? So with A, they want you to demonstrate inheritance. So inheritance, and they want physical code. So you can remember inheritance, soccer is a sport, golf is a sport. So we can use any of those classes to demonstrate inheritance. And they even told you that it is a base class. They shouldn't have told you that. You're supposed to figure it out. They're very lenient sometimes. So sport, we already know it's a base class. And I just want you to demonstrate inheritance. They just want that line that demonstrates inheritance. They don't want a lot of things. So I'm going to choose any child class, which is soccer or golf. So let me choose soccer. So remember, usually you say public class followed by the name of the class. So public soccer and then end class to end the class definition, right? And then to denote inheritance, I use the keyword, come on, I use the keyword inherits, right? Followed by the base class, followed by the base class. So what is the base class? The base class is sport. So here is the actual inheritance. And then done. There's your 3 marks. Yeah, don't waste time. This should it's 3 marks. It should cost you 3 minutes, but then you can write it in less than 3 minutes. So you can actually finish earlier than expected in your question paper. Especially if the UML part, you understand the classes that or the image and everything, the problem you understand, then it should be that quick. And then enumeration. For the enumeration, it's simple. Remember, we have 2 types of classes, right? Or 2 types of sports, which is soccer and golf. So I will literally do that. I forgot how to. Okay, with an enum, you have to make it private, right? Remember, you say private enum followed by the name. So I'm gonna say E sport, right? They're checking a lot of things. You see this E here. It's very good because there's already something called sport, which is a class. If you just leave it as sport, it's gonna crash. Then you're gonna get wrong, lose marks there. So I'm gonna call it e-sport to denote that this is an enum for sports. And then I'm gonna say and enum, right? And then what type of sports are they? So I'm gonna use soccer, golf. I know they don't, for you guys, they don't take it. Sometimes they do it, sometimes they don't. But enums, remember, an enum is basically you're taking all the constants and putting them in one thing. That's pretty much an enum. So remember, constants, they should be in uppercase. So what type of sports do I have? I have soccer, and then comma, I have golf, right? So these are the two types of sports that I have. And you need to put that comma to denote that, go to the next line. And they didn't specify the numbers you should use. If they specified initialize this to that or starting at this number, then they could say, you say is equals to 1. If they said their enums should start at 1, if something like that. But then that, I'm sure that's usually like the sub when you write the supplementary exam, because they want you to fail. So they'll ask, did it harder questions there. And then polymorphism. So polymorphism, basically when you have many forms, right? So how would you demonstrate polymorphism? And it's only 2 marks. So let me think about it. How would you demonstrate polymorphism? Using the classes, demonstrate that you understand the concept. And they said write sufficient code. It should be enough to demonstrate all those things that are being specified here. So we have this polymorphism. Let me see. Polymorphism. So polymorphism, right? I could, I don't know how, because the only way you can denote the polymorphism is if you have some function, right? They didn't specify, right? They didn't specify. But then remember, polymorphism, right, is basically when one function takes in multiple forms. So for example, like the output function that you've been having, you can define it in the base class. And then by polymorphism, right, by polymorphism, it basically means that we are using one object to actually call that function. But in that function, depending on what it's instantiated to, we get different output. Because remember, when you have this, remember in your form, you create like a sports array as sport from the sport class. And then once you have, and then you instantiate, blah, blah, I don't need to know all those things. So I have this, and then I demonstrate, to demonstrate polymorphism, right? You'd have sports at I or whatever, and then dot output, right? Something like this. Remember, this is how we demonstrated the polymorphism. Why is polymorphism? Because this sports object stores different types of sports. Remember, we also upcast. Remember upcasting. We upcast in our code, and then in this sports array, it ends up storing different objects. It stores a soccer, it can store golf, things like that. So this means this output function is polymorphic, meaning that it has multiple forms. It can output in a golf, can output even baseball, it can output rugby, can output a lot of things. So it takes in many forms. So I don't know if this is how they want you to define it. So I'm going to define it in this way. Because if they said, let me see. Yeah, that's the only way I'm thinking about it. And that's also the only way they taught you. So I'm thinking about it in this way. But then remember, I needs to be within a for loop. So for I as integer, is equals to 1 to n sports next I, like this, right? And then dot output, right? And then by output, you can put it in a text box, right? So txt output dot text, and then you can just say ampersand equals to append, right? Or you can, there's multiple ways you can approach it, or you can say dot append text and then you pass in that polymorphic function, right? But then they typically use that append text function, so just use it. So polymorphism, the polymorphism part is this part over here, right? But then I'll just put it, I can't take this comment and put it within here. It makes no sense. You put it in a line of code. So yeah, that's the polymorphism. And then what else? Composition. So composition, you basically need to demonstrate that something is a part of another thing. So that means I need to remember the only way I can demonstrate polymorphism here. I don't know about CSGO. I don't know about this. So let's Google that. CSGO. What is CSGO? Yeah, I don't know what that. I don't know what CSGO is. Is it actually a game? Yeah, I don't know. Okay, I see. I think it's like all these three classes are different types of sports. Yeah, I think that's the case. And we have FRM. So I want you to use critical thinking. Remember FRM, what I've been saying, for those who actually take the time to watch my videos, I've been telling you guys that the form is actually a class on its own. Remember, you say public class, FRM question 3. It's a class. So all this time we have been also doing composition here, right? The whole time. And they said using these classes. Don't use anything else. Using these classes. So don't try anything spiritual. So each form, and then here I'm gonna create that array. So private sports. Don't worry about the fact that I used it in the previous question. Remember in the previous question, I didn't specify public class FRM form because that was not the point. I was trying to demonstrate this, right? Or you can even just omit it entirely. That's fine because the code is explaining itself, sports. Or you can just even omit the for loop and just put this one line. You can do that. But then they said, right, sufficient code, just enough to demonstrate. So I think this should be fine. This should be enough. And then here, this is where the composition is. Like I said, I think for you guys, they don't talk about aggregation, but then this would actually be aggregation, not composition, but it's fine because the form can exist without sports. A sport, I mean, can exist without form. And then E, right? So E is downcasting. So we're casting downwards. So to cast downwards, I need to demonstrate that I have like many objects, right? Like the objects, I need to declare them. So remember, this is just enough code to demonstrate that thing. You see, 4 marks, enough code to demonstrate it. So what's the enough code? So I need to say private soccer, right, as soccer, and then private sports. They said downcasting, right? So I don't have to have multiple sports. So I can have sport as it is. Remember, array is not always needed. Here it was needed because I wanted to demonstrate polymorphism in many forms. It needed to be an array. Here, I don't necessarily have to make it an array. The main important thing that they should know is that, oh, this is a base class, this is a derived class or a child class. So now how do I demonstrate downcasting? I basically try to store sport into soccer. I try to store this sport, but then sport is an base class, this is the child. So I have to what's that? What's that? What's the opposite of? I have to demote. Yeah, I have to demote this one, meaning it's going to go downwards. It's called downcasting because if you look at the, let me show you what it means to downcast. If you look at the inheritance hierarchy, right? Um, just create, save, and then that's it. So if you look at the, I'm gonna make a simple example because some people they can't see this. So I'm gonna have sport, right? That's my base class, right? Sport is my base class, and then I'm just gonna style it, give it a nice cute color, then put it here, then give it a color. So this would be soccer, right? And remember the family tree, it goes downwards, right? So if I'm trying to store an instance, right, or an object of sport into here. So what am I doing? That means I'm trying to go from here to here. So I'm going down. It's like going down the stairs. So I'm down casting. Casting meaning I'm converting. So I'm converting downwards, or I'm converting from a type that's there at the top to a type that's there at the bottom. So it's downcasting. So hence, and downcasting is not, it doesn't happen implicitly, right, or indirect. It needs to have, you need to do it explicitly. That means manually. So I need to say direct cast. So we use direct cast for that, right? Okay, I need to change this to a small letter spot, right? So that it avoid, so that we get rid of the confusion that which is the instance, which is the data type. So the instance starts with a smaller letter s. And then the way you use direct cast is that you start by putting, how you use the direct cast, right? You start by putting in the instance. Uh, come on, instance, and then the data type. So the instance that I want to cast, it's this one, sport to the small letter. So sport, the small letter. And then I want to cast it to what data type? So remember, I want to downcast it. Remember, this is soccer. So it needs to be equal. So at the moment, I have something of soccer type on this side. And then on this side, I have something of sport type. That means this sport type needs to be converted to soccer in order for the equal sign to be actually equal, right? For them to be, for it to copy. So therefore, I'm going to change this and say downcast it to soccer. So now this is going to downcast. But direct cast, they typically use trycast. The difference is that with trycast, it returns an exception if it's not found. So let's just use the trycast. And then direct cast doesn't return an exception, right? So let's use trycast because that's in the slides. When they demonstrate downcasting, they use trycast. So downcasting, which is, it's actually good because we can actually fail to cast. Why? Because what if it's not, there's no spot inside, there's no soccer here at all. So that means this can fail. So with the try, at least when you throw an exception, we can handle it, right? Remember, when you throw an exception, we can catch it, right? So and then D, let's see D. Now my throat is painful. So let me see. Downcasting. Wait, did I skip something here? Oh, it's not D, it's F. Overriding with extension. I'm not sure what they mean by overriding with extension, but you just need that show overriding basically, right? So how do we show? We need classes, right? Yeah, I think that's why it's kind of like worth a lot of marks. So I need to choose which class, right? Remember, it's overriding. So I can just define a method inside of my base class, right? And then let's see. So each each sport, right? It's played different, right? You play it different. Soccer, you kick. With golf, we use that tool. We use another tool to hit the balls, right? So the play is defined differently. So hence, I'm gonna create a play method, right? So I'm gonna create public class. I need to demonstrate everything, right? So I need to say public class, my sport class, then and class, right? And then this is my class. Then I need to define a method. So I'm gonna say public. Um, I'll to make things simple, right? I'll let me see. It's supposed to what play, right? Play and play is play is defined in different ways. So what I would do is I'll say must override, right? Which will make this class must inherit, which is fine, right? We are flexing that you know all of these things. So I'll make it a must override because I don't want this hassle of trying to return right something. So you play each sport is played different. So I'm gonna write it in full and call it play sport. And I'm gonna make it a sub. So a subroutine, basically which is void, means that it doesn't retain anything. And then I'm going to have a why did I make it must override? Because I didn't want to make it overridable. Remember, overridable, you must return something at least. You can't do that, it's up to you. Remember, this is an open-ended question. You can choose overridable, and then remember, it's a subroutine. I don't have to actually write anything. So this is the first approach. The second approach is just you say overridable. That means there's no need for must inherit. Then you need to come here and say end sub. Then you just leave it empty. It's fine. But I'm just gonna say must override because it's going to be empty either way. So I'm going to say public class um, let's see what's this soccer, right? Or I can just say golf. I haven't used the golf class, so let me just use it at least once. So golf, and then I need to also specify that it inherits, right, from sport. And then I'm going to, since it inherits, that will force me to also what? Override. If I don't say inherits, they won't really know that it actually inherits. So you'd have to actually say inherits, then so that they know that, oh, that means you have to override. And then the other thing they want to know is the overrides keyword. And then sub, and then play sport, and then and sub. And then all I'm just going to output here, you don't have to actually do anything, right? But I'm just going to output something. So I'm going to say MSG box, and then I'm going to say output the string play golf, right? So that they know that, okay, this person, this is to play golf because they'll see, oh, logically, play sport, these sports are played differently. So you understood the assignment. You knew, oh, overriding means that it's implemented differently. Each class defines this thing or this functionality in a different manner or in a different way. So this is all the code that I think they want to see. With extension, I'm not sure whether they mean like overrides keyword. Yeah, I think they need with the extension like the keywords. I think that's what they mean. So yeah, I think that's what they actually meant there. So that's pretty much it. That's question 3. And then clearly indicate where each class begins and where each class ends. So this is clearly indicate where you are attempting to illustrate a particular concept. Wow. If you don't follow instructions, they say indicate where you are demonstrating it. Overrides with extension. So you need to demonstrate where you are demonstrating the concept. I've been doing that the whole time. I have. Enum, you don't have to specify where because it's not applicable. It's you can see it's an enum. But in things like polymorphism, downcasting, and overrides, you need to specify exactly where. So those ones are very important. And then question 4. Question 4 is the diagram, right? It's a collision handling thing. So with collision handling, um, this is really annoying because I have to do quite a lot for collision handling. So for collision handling, I'm going to switch to this side. So let me see. Mm, then question 5, question 6. But question 5 and question 6, did make, I did actually do, yeah, I did do this thing. We did do past papers. So for now, I'll just end on question 4, then I'll see question 5 and 6 later. Or in tomorrow, I'll see when I upload. So let's look at this. So the things you need to understand, linear probing, right? It's linear. It means you go in that order. So what you just do is you add them one by one. You see a collision, you add it to the next line. So there's a slight variation between linear probing and two pass. Two pass, what it does is like you add what's currently there, the first pass, right? The first time. And then you now you leave the collisions aside. Then in the next try and in the next pass, you now add the collisions, looking for the next available space. So that's linear probing. And then synonym chaining, right? It's basically, what's the other one again? Is the, what's this, overflow? What the, where you put in the names separately. But then the only difference with synonym chaining is that you chain them. You're gonna put a pointer and then you say it after this, this is there, this is there, and then so forth. And then bucket address, you put it in terms of buckets. So I'll demonstrate how to do that. Okay, so almost 2 hours, so we're still on the right track. So I'm gonna delete this, right? Can I actually make a table out of this? If I do, it's gonna be quite a lot of work. So let me see. 1, 2, 3, 4, 5. Let me see. You say position and then record. Okay. So 1, 2. Oh, okay. It's 1, 2, 3, 9, 11. So I need 11 rows, right? 11 rows. So what I will do is I'll do this. And then 1, 2, 3, 4, 5. Right, and then I'll do this. So it's 5, right? And then I'll use common sense. 5 times 2, that's 10. Then I'll just do this to save time. And then 1, that'll be 11. So the thing is, I have a small screen. So So there it is, right? Um, so there it is. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I miss something? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I actually had two extra. Okay, so there we go. So I have 11. So I need to have position and key, right? No, position and record. Yeah, it's called position and record. So for linear probing, right? Let's start with linear probing. Linear probing, you just put them in that order, right? One after the other. You find a collision, you look for the next available space. Um, so let me try to zoom in a bit. So, okay, I need to have a heading for these things, right? So I'm going to do this. Then I'm going to go here. Okay, so let me increase the font first. So increase the font. And then there we go. Yeah, so this will be, if I'm not mistaken, it starts with the, is it position or record? Okay, start with the position. So position, and then I need to make it have colors, right? And then we need to have the record row or the record column, I mean. And then I put it next to it like this. And then this will be the record, which is the actual record, right? And then to I should have, but then it's fine. It's too late now to complain that I didn't color them when there was still few before I copied and pasted them. Okay, and then yeah, so just be patient. And then bam, and then bam. Okay, we're still not done. Okay, and then this, then that, then this, then that. So in terms of position, right, we need to find the maximum position, right? And then we continue from there. But then it's fine. Okay, it's fine. Yeah, it's fine. We just count from 1 to 11. It's fine. I don't have to look at these numbers. It's fine. We just count from 1 to 11 because I know for a fact I have 11 pieces of date, right? Okay, so we are done here. So I can close this and I've saved it. So we are done there. So let's go back here. So there's our records, and then now I need to put in, okay, no, this is not gonna work. So I need to increase the font here. It's quite a lot of work. And then this will be 1. And then this will be 2. And then this will be 3. And then this will be 4. And then this will be a 5 until we get to 11. Okay, this is 6. And then, okay, 7, 8, 9, and then 10, and then 11. Some people might be concerned, why are we doing collision ending? Remember when we're doing what is random access files? Remember we hashed the student IDs, right? The problem is that that formula, it's a very simple formula using the prime number division, the remainder division algorithm. It's a very simple algorithm. There's bound to be collisions, meaning that we happen to generate the same hash number or the key number, right? So in order to do that, there's algorithms to solve those collisions or how to handle when we have collisions. Hence, they're teaching you collision handling. So let's do that. So there's the collision handling. So let's see. So starting with lamp, it's at position 1, right? Remember, starting with linear probing. What I would do is I'll save each image with a specific name. I'll call it linear probing, synonym changes, chaining, and then like save one at a time, right? So we have lamp, which is at position 1. So the record is lamp and it's at position 1. So this was not, I didn't plan this well, but then it's fine. Let me see if I can fix it. Okay, it's fine. Let me just do this. Okay, it seems like I can't, but it's fine. So I'm just going to stretch this. Like I said, it seems like I didn't plan this well because it's actually smaller than it's supposed to be. Because some words, yeah, don't mind me. It's my first time actually making a video on informatics past paper because I just assumed students would understand it since informatics is straightforward. Plus, you attend class, they show you these things in class. Okay, there we go. So my position and record. So the record that you have is lamp, it's at index 1. Linear probing, right? The way it works is that you keep adding the records where they in that specific number. When you have a collision, right? You look for the next available space, right? I know it sounds a bit, let me see, let me think about it. The 2 pass is during the first pass, okay, yeah. Linear probing is actually like that. You look for the next available. That means it's going to be weird because some records already have their own keys, but then we might end up facing collisions and then we might face weird situations, but I think they do it the right way. Linear probing, like I said, you just keep adding, right? When you find when you get a collision, right? Let's say something's already it's already at 1, right? Okay, yeah, collision. Okay, yeah, I see. It's already at 1. You move to the next block 2. If block 2 is already occupied, you move to the next block until you find an available block, moving downwards. That's linear probing, basically that. The 2 pass one, what it does is you ignore the collisions and then just put the ones with no collisions. Then in the next step, you do linear probing, which is basically looking at next available places. That's the 2 pass algorithm. So keep note of those subtle differences. So lamp index 1. So copy this. Okay, I can't copy this. I can copy this though. So this will be lamp, right? So this is lamp at index 1. So far, no collision, right? Nothing. And then position 2, it's carpet. So you see no collisions, nothing. So carpet, right? So we have carpet, done. And then index 5 or position 5, it's bed. So I need to go to 5, right? And then I put bed. And then so far, so good. And then couch at index 7. So I need to go to index 7, and then I put couch, right? Index 7. So far, so good. No collisions, right? And then, bam, we have a problem. Bow, it's in index 1, and index 1 already has a record. So what happens is that you keep going downwards. You start here, you check here, does it have? Yes, it has. You check in the next block, does it have? No, it doesn't have. So put it there. So that's linear probing. Two pass is still linear probing. The only difference is that we start by skipping the collisions. That's the only difference. Yeah, we just skip. We just pretend that like they're not there, but we put a tick so that we remember that that's where the collision is. So in this case, we handle it as we go. It's linear. We go in one way. We don't go and then go back. We know it's in one way. It's called linear probing. You go in linear form, going downwards. You don't go back. You go downwards, right? That's linear probing. And then bow, it's at index 1. So we started index 1 where it's supposed to go. It's occupied. We go to index 2, the next block, it's already occupied. We go to index 3, the next block, oh, it's empty. So I can put it here. So then I put the bow here, right? And then we've handled the collision. And then mouse, there's another collision too. We're trying to put mouse 2, it's already occupied. What about index 3? It's already occupied. What about here? It's not occupied. So I can put it at index 4. That's mouse. Remember, it's linear probing. I know there's some record that already has 4. I know, but we are using the algorithm called linear probing. You go one way. You don't put them aside, whatever. Even if there's supposed to be another one there, it's fine. Because you see these 4s and be like, well, why don't you prioritize that? No, it's called linear probing. We're going to go in that direction. And then table is supposed to go at 4, but then 4, remember, we just recently used it, so it goes to the next block. So 5, wait, 5 is already occupied too. What about 6? It's empty. Then we're gonna put it at 6. What is it called again? Table. So I'm gonna go here, and then this will be table, right? So far so good. And then 4 again, painting. And we keep checking the next block. So starting at 4, 5 is available, is occupied, 6 is occupied, 7 is occupied, 8 is not occupied. So we can use 8. So this will be painting, right? And then dog, it's at 6, which is already occupied, 6. So we keep looking for the next available block. I'm sure you get the idea now. So it's going to come here, dog. Yeah, you should get the idea now. And then red, it's at index 8, but then index 8, it's occupied. So it needs to go from 8. What about 9? It's also occupied. What about 10? Oh, 10 is available. So I'm going to copy this. and then it's red, and then last one, it's bug. So we're gonna start at the top, we go down checking the next available until we realize the last one is the only one that is only available, which is bug. So this will be bug. So this is pretty much the format. This is the answer. Then I'm going to delete this. So this is the actual answer. So this will be the answer for linear probing, right? So I'm going to save this as, I cannot save as export as PNG, export, and then the name, this will be question 4, right? Yeah, question 4. So question 4, the linear probing, right? So linear probing, with linear probing, you don't have any, how do I put it? You don't have any notation or any symbols, right? So that's fine. We just leave it as it is. So synonym chaining, right? With synonym chaining, it's pretty much the same thing, right? But then since we're going to have issues, what I'm going to do is I'm just going to delete all of them to just make life simpler. I'll genuinely just delete all of them. So with okay, I'll leave lamp because I want to use that. So let's start here, right? Remember synonym chaining, right? You need to have like this. So you need to have here a pointer column to help you point to that other I forgot what the heading you put here. I forgot what heading you put there, but then okay, I think you say overflow if I'm not mistaken. So I'm gonna go to the top here and I'm gonna say overflow. Yeah, I think you say overflow there. And then I'm going to copy, paste. Okay, so let me do this. Let me paste multiple of them and then yeah, there's quite a lot involved if you're doing this thing on a computer. It was a piece of a pen and a paper, then yeah. Okay, still quite a lot. So 1, 2, 3, 4, 5, 6, 6, right? So yeah, 6. There's 11, so I need 5. I need 5 of this. Since I need 5, so let me copy this 5 before I shift them. So copy this, and then I shift them here. Right, and then there's the other 5. There we go, done, right? And then I need to also add them this side in the pointer column. So 5, 10, then I'm left with 1. Then I'm gonna put it here, right? So I hope you can sort of like see, right? So let me make it a bit smaller like this so that you guys can see. So with the synonym chaining, right? You're chaining, right? You're just pointing. So basically the way it works, the way it works, right? If I have a record here, if I already have a record, right? I put it in the next block, in the overflow block, and then I put an arrow to point to say that this was actually supposed to be at this position 1. So I put a pointer there so that they know. And this was supposed to be at position 2. If it was supposed to be at position 2, if it was supposed to be at position 4, from position 4, it points to that name. So that's pretty much that. That's the formula. Straightforward. So synonym chaining. So let's go back. So carpet is number 2, right? So copy this, and then I'm gonna put carpet here, 2, right? So far so good. And then bed is 5. It goes to index 5. That's bed, or position 5. And then couch is at position 7. So I'm gonna go position 7. And then I say couch. So there we go. And then we start facing collisions. So bow is at index 1, right? So we have a collision. So since we have a collision, we put it in the overflow, right, block, which is here. So this will be bow, right? But then I put a pointer to it to show that it was supposed to be in this row or that position, right? But then pointer is simpler than to go around here and then do, you see, to to you see that it become, my diagrams look messy if I do this. Yeah, so we actually have to create a separate pointer block or pointer column, and then we actually point to it. So let me choose arrows. Let me choose an arrow to use. So I'll choose an arrow. Why is it doing this now? So there's the arrow, right? So I'm gonna try to minimize it to make it a bit smaller. Okay, that's fine. Then this arrow is gonna go from here to this block, right? So this arrow, just give it, let me see, I just give it a color, right, to make things simpler. So you see, it was supposed to be within this row, but then there was an overflow, or it was already occupied, so I put it in a separate overflow column, right? So that's pretty much what we have. And then we need to have put in the next thing. So mouse is at index 2, which is also in overflow because mouse is already occupied. So I need to put it in the overflow block, mouse, and then I put a pointer to it, which is just going to be simple because I already have a pointer. I'm just going to copy that, paste it there, because it happens to be here because they happen to be in the same row, right? They like are following each other. Sometimes it can be here and then it points there. It can happen. So don't cram. So mouse and then table has no collision. You see that the diagrams start to look different now. So here table goes where it's supposed to go. But then printing, which is supposed to get index 4 to, is causing a collision. So we put printing in its own separate overflow block, right? Printing, right? And then I put in an arrow from here, table, right, pointing towards day, right? But from table. So that means I need to make this a bit shorter, but let's start by putting it there. And then make this a bit shorter. And then turn it around a bit. Then shift it up a bit. Okay, so that should be fine. Okay, I deleted this thing by mistake, so this should be there. So yeah, there it is. So from 4, a pointer pointing to there, and then 6, which is dog. So number 6 at index 6, it should be a dog. So it goes exactly where it should go. And then 8 is a rat. So number 8 is a rat, and 8 is available, right? The ones that are available, I'm just putting them there. And then bug is 1. So we have collision again at 1. So I need to put it in the separate block here, which is the bug. And then I need an arrow from pointer from there to there, right? So I'll put it here, and then it needs to go from 1. And then let's try to do that, and then switch that to there. Or I can just do this. Or I can just do this. Let me see. Yeah, I can do this. So let me come up with another technique. See now. Why is not allowing me to? Mm, okay, just give me a sec. Okay, I'm gonna trick it. It thinks it's intelligent. I'll trick it. So at 1 is bug. Then I change the shape to this, right? And then I change the color to pink, right? Or I can just use a, so let me see. Okay, I think that's fine. But just know it's coming, you see, as you can see, it's going from 1 and it goes to bug. So yeah, this is pretty much how the diagram should look. Obviously on paper it's going to look a bit better, but this is the answer. So this will be synonym chaining, right? So I'm going to save this. Okay, not save, export. Export as PNG, export, and then question for synonym chaining, right? Synonym chaining, and then we are done with synonym chaining. So let me just double check so that I can see it. Yeah, it's pretty clear to me. So yeah, so now we need to do the whole bucket thingy. So the bucket, right? It's like, I mean, it's buckets. You're gonna have buckets, right? So I'm gonna have bucket size. Remember, it depends on the bucket size, right? Um, so the file can only handle 18 values, given that the records are inserted in the file below. Yeah, I made a mistake. It says the files can handle 13 values, right? 13. So I'm not sure if it's supposed to go from 1 to 11 or 13. You have to confirm with the lecturer. But I only see 11 records, so that's why I used 1 to 11. But this here it says 13. I guess they're just putting it there for information. But I assume they're supposed to, you know, do that. Like explain in class. They're supposed to explain in class. So the whole with the bucket size thing, you need to have it's a basically a bucket. I think they start from 0. But then this is weird. Bucket size 1. That's honestly weird. Bucket size are usually bigger than that. So let me check. Okay. Not me deleting this, but at least I still have it on my not the do I still have it? I hope I still have it. Where is it? Maybe on desktop. Okay, it's on documents. Okay, it's on documents. Still have it. But bucket size, usually get the bigger bucket size. I don't know how come they say bucket size of 1. Isn't it supposed to be? But I think, let me see. What wasn't this paper too? I think this was a supplement. I think I took a supplementary exam, if I'm not mistaken. But with bucket size, you're supposed to have the bucket. So a bigger bucket size, I mean. So informatics. So let me search. Let me just check this question paper. Yeah, you see, they usually give you bucket size 4. So I think with bucket size, oh yeah, I remember. With bucket size, if it's small, right, you are allowed to increase it. If there's base, they just give you a bucket size. I think the bucket size, the way they give you to, right, it's sort of like a suggestion, like a minimum. And they're telling you that's the minimum, right? It doesn't mean that that's like the maximum. Keep that in mind. So what we're going to do is, since we're going to have bucket 1, bucket 2, bucket 3, and so forth, right? But then I know for a fact in our case, right? Um, in our case, since we going to we're going to what is this? Have multiple we're going to need at least a bucket size of 2. So you just increase by 1 if the bucket is full, right? So in my case, I'm gonna use 2 buckets, right? So bucket 1, bucket 2, right? So I'm gonna increase it by 1. So I'm gonna do this, and then let's start. So I'm gonna start with lamp, right? It's at index 1, straightforward. Then I go to carpet, right? Which is at index 2 or position 2. So I'm gonna put carpet here. So there's carpet at position 2. We start with bucket 1, right? Then we only use the second bucket if for that row it's already occupied. And then we have to need a third bucket if in the first bucket that row is occupied, and in the second bucket that row is also occupied. Then we would have to be forced to create a third bucket. So we have that. So bed goes to 5. Index 5 is bed, just like your sleeping bed. And then couch is index 7. So I'm gonna go to index 7. That's couch. And then index 1 is bowl. So we see bowl, the first bucket is already filled at index 1. So we need to use the next bucket. So at that specific row, don't come and put it somewhere there. No, in that specific row, they need to match, right? So it's bow, right? So bow bucket 2, and then we've handled this collision. And then we have mouse, which is at index 2. So index 2 is already occupied in the first bucket. We need to go to the second bucket. So therefore, I'm going to put mouse here in the second bucket. And then table, it goes to the fourth position. So I'm going to go to the fourth and then put table. And then painting is at fourth again. So we have a collision. So it needs to move to the next bucket. In that specific row, right, we have painting. In that specific row, row 4. Don't do spiritual things. And then dog, index 9, right? No, dog is at index 6. So why am I saying 9? Index 6 is dog, and there's nothing at index 6. So it will go into the first bucket. And then rat is at index 8. So we're going to check index 8 is available in the first bucket. Index 8. So this will be red. Right, so that's red. And then the last one is bug, which is at index 1. It's bug 1, 1. So you see now we are forced to have a third bucket. So I think they're just testing your understanding. I think they gave it to you on purpose to see that you understand that the buckets need to be increased when you see fit, right? When you see that you're supposed to increase them. So this will be what's that on bug, right? Like the bug in your code. Okay, so okay, so that's fine. And then now I need to add this, finish filling up this bucket with the empty rows or with empty cells. Okay, so we're pretty much done with everything. Yeah, so that's bucket 1, bucket 2, and bucket 3. So you see the bucket size, it ended up increasing to bucket size 3 because we saw fit that we put an extra bucket where we saw that it's fit to be added, and then there was a need to add it, and then we did add it. So this will be your final answer, right? And then I'm gonna export it as PNG, export, and then give it a name. So question for bucket addressing, right? So yeah, that's pretty much everything for today. I'll see in the file handling because I did explain this. The file handling part, I did explain thoroughly. Because if I do it, I'm just going to be going over it, skipping things. This should be straightforward. Calculating all those things should be straightforward. So that's it. I'll see if I'll make the video, but then I doubt it. Just for now, just revisit the videos that I posted, the ones that most of you didn't watch. This is your opportunity to go watch them. So yeah, that's it for today. And don't forget to subscribe.